Right, let's continue with question 7. Okay, a group of 30 runners are randomly chosen and their time machine minutes taken to complete a marathon run is recorded in the table below. So you're given a frequency distribution table. Okay, with the class interval, how many classes do you have here? 1, 2, 3, 4, 5. Okay, you have 5 classes, and then you're given a few more columns, and you will ask to what? Fill in all the blank cells. Okay, have you fill in all the columns? Are you able to fill in?
Yes, yes.
Yes. Okay, great. So complete the blank cell. Okay, let's question 7. Where should I put it? Maybe I'll put it below here. Okay, so you have the time, the midpoint, frequency, relative frequency, cumulative frequency, and cumulative frequency. Okay, this is 1, 2, 3. Okay, 20, 95. Okay. Right. Let's start with the midpoint first. Okay. Yes. Okay, please make sure your mic is mute if you have no questions for me. Okay, midpoint for the first class is 3. How do we get 3? Is because 1 plus 5 divided by 2. Okay, the lower limit plus the upper limit divided by 2, we will get our midpoint. Okay. So how about for the second class? For the second class, where is the midpoint? 5 plus 10 divided by 2. Okay, 5 plus 10 divided by 2, you have 7.5. Why? Oh, this is the transcripts. Okay, so for the second class, okay, the midpoint is 7.5. Okay, 5 plus 10 divided by 2. So, what is the lower limit? Lower limits have explained this yesterday. Okay, the smallest value in the class interval. Okay, the upper limit is the largest value in the class interval. Okay, so you add up together, divide by 2, you get the midpoint. Okay, so for the third class, 10 plus 15 divide by 2, you have 12.5. Is it that? Okay, let me check. Okay, 10 plus 15 divided by 2. Yeah, 12.5. Okay, the fourth class, for 15 plus 20 divided by 2, you got 17.5. And the last class, 20 plus 25 divided by 2, you get 22.5. Okay, how about the frequency? Okay, frequency are given 2, 3. Then the third class is not given 10, 8. Okay, and then 30. So where is the frequency for the third class? Frequency for the third class, it will be what? Yes. These students, do you have any questions for me? No. Okay, so to find the frequency for the third class, okay, you will take the total frequency, okay, minus the frequency for the other four classes. Okay, then you'll get the for the third class ready, right? Okay, 7. Okay, then next what we have is
Teacher, I can ask you about F.
yes.
How
Yes, what
I
is your
find out about F?
F is the frequency.
Yeah, thank you.
Okay, I'm writing the short form from a table above. Okay, relative frequency, I write it as RF. Okay, please refer to the tables given by the questions. Okay, so how to get the relative frequency? Okay, we have done this yesterday as well. Okay, to get the relative frequency, you have to take the frequency of the class divided by the total frequency. Okay, so 2 divided by 30, you got 0.67. Okay, 3 divided by 30, you got 0.1. Okay, 7 divided by 30, you got 0.23. Okay, 10 divided by 30, you got 0.33. And then the last class, 8 divided by 30, you have 0.27. Okay, next is the cumulative frequency. Cumulative frequency, you will add up from the first class. Okay, you add up the frequency from the first class. Okay, you accumulate. So first class cumulative frequency, it will be 0.67. Second class, it will be 0.67 plus 0.1. Okay, 0.67 plus 0.1, yeah? So you have 0.77. Okay, then you accumulate, okay? So for the third class is 0.67 plus 0.1 plus 0.23. Okay, so 0. Plus 0.23, so you get 1. Sorry. This is adding up the relative frequency. Sorry. We should be adding up the frequency, not the relative frequency. We should be looking at these F columns. Yeah, my bad. So this one, cumulative frequency, we will start off with 2. Okay, then 2 plus 3. Okay, 2 plus 3, you got 5. Then plus another 7, you got 12, right? Okay, 12. Then plus another 10, you got 22. Then plus the 8, you got 30. So it's always accumulating the frequency starting from the first class. Okay, then our last column is what I did just now. Okay, accumulate the relative frequency. Okay, this time, okay, we accumulate this one, then we got the cumulative relative frequency. Okay, so the first class, it will be 0.67 2 divided by 30. Sorry, it should be, it's not 0.67. No? It should be 0.07. Okay. 0.07. Yeah. Or else the value is too big, right? Okay. So here 0.07. Okay. Second class, you take 0.07, you add up 0.1. So 0.17. Okay, accumulate. Then 0.07 plus 0.1 plus 0.23. Okay, so you will have the cumulative for the third class 0.4. Then you continue to add up. Okay, plus 0.33, you will get 0.73. And then the last one, you plus 0.27, you should get 1. Okay, 1.00. Okay, so this is the answer for question A. Okay, next, compute the following sum. Okay, calculate the total MF, total M square F. So for this, okay. So for question B, okay, you may want to okay, so let's okay okay, let's create another table. Okay, construct another table 3. Just copy back the M and the F columns. 22.5. Okay, the F is the frequency 2, 3, 7, 10, and 8. Okay, so next is we create a new columns to calculate the MF. So you take the midpoint times the frequency. Okay, you calculate the MF for every class. Okay, for every class. So this one again have to use the calculator, calculate one by one. Okay, 7.5 times 3, 12.5 times 7. Okay. Done. Okay, so you add up these MF columns, you should get the total MF. Okay, you add up these MF columns. So 6 plus 22.5 plus 87.5 plus 175 plus 180. You got 471. Okay, please let me know if I calculated wrongly. Yeah. Okay. But sometimes I may make mistakes as well. Okay. All right. Next is to calculate the M square F. So to get this, you will square the midpoint first. So you 3 square, then multiply by the frequency 2. Okay. So you got 18. Okay, so for the second one, 7.5 square times 3, you have 168.75. Okay, 12.5 square times 7. 0.5 square times 10. Okay, so usually the values are quite bigger. Okay, because you are squaring the midpoint. Okay, so it's 50. So when you add up the last column, you will get your total M square F. Okay. So let me calculate the last column. Okay, 8393. Okay, that's it for the answers. Question B. So far, can you guys follow? Can I? Okay, move on to question C. Calculate the sample mean and the standard deviations of the group data. Okay, so you will apply the formulas. Okay, if you're not sure which formulas to use, okay, refer to the last few pages. Okay, right now we are solving the group data. Okay, we are solving the group data. So you look at this through. And then for group data, are we having the populations data or the sample data? Okay, this is a sample data. Okay, so we will use these two formulas. Okay, we use these two formulas. So total MF and total M square F, we have found in question B already, right? So move it back to the questions. Okay, so to get the sample mean, okay, since this is the first time, let's write down the formulas. Okay, so 471, N is the total frequency. Okay, we divide by 30. Okay, how about the standard deviations? Standard deviations formula is total M square F minus the square of total MF divided by N, and then the whole thing divided by N minus 1. And don't forget about the square root. Okay, so M square F, you got 8393. Okay, minus 471 square divided by N is 30. Minus 1. Okay, so let's calculate this. What answers do you get for mean? Okay, you got 15.7. Okay, standard deviations. Okay, this one. Okay, standard deviations, it will be always positive. The answers for standard deviations and variance is always positive. So if you got a negative values, that means your workings are wrong. Okay, the standard deviations I got is 5.87. Okay, you guys double check your answers. Any questions? Okay. Question D is to construct a relative frequency histogram. Okay, for the above data and then use the title given. Okay, so here this question is asking for what type of histogram? Relative frequency histogram, which means the y-axis, okay, of the histogram should be relative frequency. Okay, yesterday we have sketched the histogram, but the y-axis is frequency, but here we are using relative frequency. Okay, so let's draw the graph. Okay, histogram. So for your y-axis, okay, we are using relative frequency. Okay, so let's look at the relative frequency columns. Okay, so we look at this one, this one. Okay, 0.07, 0.1. Okay. 0.05. 0.1, 0.15. I think I have to draw it smaller bit. No space. 0.5, 0.1, 1.5, 2, 2.5, 3, 3.5. Okay, depends on how much space you have. Okay, because I'm trying to fit in the relative frequency that we have. 2, 5. Okay, if you have more space, then you could draw it bigger. Okay, the measurement scale you can also have a better gap between them. Okay, this is 0. Okay, so for the x-axis will be our variable here, which is the time, Okay, so for the first class, the relative frequency is 0.07. So 0.07, it will be here. So you will draw a rectangle, okay, with the height represented by the relative frequency. So 0.07, somewhere around here. Okay, next one, next class, relative frequency is 0.1. Okay, so we continue draw up to 0.1. So make sure the size of the rectangles, they are the same. Okay, they are all the same. Next class, 0.23. So 0.23, you have, okay, around the middle. Okay. Then fourth class, 0.33. Okay, and the last class, 0.27. Okay, 27. Okay, so not done yet. Please write down the interval below the rectangle. So for this one, you have less than 5. So make sure you have sufficient space to write down the class interval. Okay, the second one, the third one, fourth one, until the last one, 20 to 25. Okay, follow the class interval given. Okay, you can refer to this. Okay, the first column of the tables. Okay, so okay, oh, we also have the title. Okay, since the title is given, so time taken to complete a marathon run. Okay, so you're just write down the title on top of the graph. Okay, time taken to complete a marathon run. Okay, write the title on top. Okay, any questions? Any questions in the chat? No. Okay, so based on the result in D, comment on the skewness of the data. So where is the skewness based on the histogram that you have? Where's the skewness? Where's the shapes?
Left skew.
Yes, okay. All right, so if you try to draw out the shape, okay, you notice that the left tail is longer. So the answers for question E is, okay, let's see, does the question tells you, okay, comment, okay, so you will say the data is left skew or skew to the left or negatively skew. Okay, because left tail is longer, or the tail is longer at the left hand side. Okay, left tail is longer. Okay, this is a left skew graph. Okay, what percentage of the runners finish the run under 20 minutes? Okay, what is the percentage of runners finish the run under 20 minutes, meaning within 20 minutes, less than 20 minutes? So what is the percentage? We can refer to the table, okay, to find the percentage. So what is the percentage? Okay, we can look at this. Okay, so if you look at the table, okay, we will look at the last column. Okay, 0.07. Okay, we look at the cumulative relative frequency. Okay, so what does 0.007 means? So if we convert to percentage, we times 100, that means 7%. So what does it mean here is, that means 7% of the runners, okay, it takes time between 0 to 1. So or 7% of the runners, okay, finish within 5 minutes, because the first class is less than 5. Okay, the time for the first class is less than 5. Okay, so how about the second value is 0.17, because this is cumulative. Okay, we are accumulating the relative frequency. So you convert to percentage, you got 17%. This means 17% of the runners, okay, they finish within what time? So the second class is 5 to 10. Okay, so that means they finish within 10 minutes. Okay, they take less than 10 minutes. So if you follow this concept, okay, what percentage of runners finish under 20 minutes? So you have up to this. This is 15 to 20, right? Okay, so you look at the first 4 classes. So the answers would be, okay, 0.73, but you have to count the percentage, so you times hundreds. So for these questions, okay, 0.73 then times 100%. So the percentage will be 73% of the runners, they finish within 20 minutes. Okay, so they could be either from the first class, okay, second, third, or the fourth class. Okay, as long as they finish within 20 minutes. Okay, any questions? You guys follow? So that's it for the question 7. And we have finished the module 1 questions. Anything you would like to ask? Is there any questions you want to ask? No? So for those who just joined, okay, thanks. For those who just joined the class, right, the meeting, if you have any questions and you want to ask me, you can go to this course page. Okay, open up this discussion room. Okay, you open up this discussion room, you click here to enter the chat. Okay, so if you're too shy to ask me through the mic, okay, you can type your questions inside here. Okay, I'll be answering you. Okay. So I'll be opening these chats until the end of the today, right? Okay, no questions. If there's no questions, let's move on to module 2. Okay, so module 2 talks about the probability, all right? Probability, we have the discrete probability, and then discrete probability distributions, where we have the binomial and the Poisson distributions. And then in chapter 6, we have the normal distributions. Normal distributions is a continuous distributions. Okay, so we have discrete and continuous distributions here. Okay, so let's look at question 1. Okay, you are given tables. Okay, the degrees conferred by universities on 1,000 business graduates. Okay, measuring in accounting, HR, human resource, and e-commerce. Okay, so a two-way classifications table. Okay, based on the table, okay, first you need to understand what is the tables talking about. Okay, so these hundreds, okay, the hundreds, okay, all the values here, it represent the graduates that comes from the majors, a particular majors, and the gender. Okay, so the hundreds here means they are 100 graduates. Okay, hundreds graduates. Okay, majors. Okay, majoring in accounting, and they are male. Okay, so that's what it means by this table. So 120 means 120 of them are majoring in accounting, and they are female. Okay, so total accounting graduates you have 220. Okay, so same for the other columns and row. Okay, total male you have 550. Female is 445. Okay, when you add up, okay, you get 1,000. Okay, so the first question is, what is the probability that the graduate is a female? So let's say you randomly select a graduate out of the 1,000. What is the probability of you selecting a female? Okay, what is the probability of you selecting a female? So how do we write? Okay, we write P stands for probability, then brackets F. Okay, F here is referring to the female. Okay, so you take the total female is 450 divided by the grand total 1,000. So the answer is 0.45. Okay. Let me know if you don't understand how to calculate. Okay, how about graduates major in human resource? So for human resource, okay, you look at the total. Where's the total? 500. Okay, 500. So how to write the working probability? Okay, that the graduate is human resource. So here we are using the H. Okay, the tables, it give you the alphabet letters to use really. H to stand for human resource. Okay, so here the total for human resource is 500. Then divide by the grand total 1,000, you will get the probability. Okay, 0.5. So that means you have 50% chance of selecting a graduate majors in human resource. Okay, when you randomly select. Okay, Question 3. Okay, majors in human resource and is a female. So you look at the intersections between the human resource and the female. So the number of graduates who majors in human resource and female is 200. Okay, so how do we write the answers? The probability, okay, human resource and female. So if you see the words, okay, if you see the words and, okay, so the symbols that we use, it will be like an N shape. Okay, this is what we call the intersect. Okay, the intersections. Okay, this is the intersections. Okay, H intersect with F. So to get this, okay, so just now I say 200, right? So take 200 divide by the 1000, the grand total, you get the answers really. Okay, how about the next questions? Majors in human resource or a female. So when you see the word or, we will use the symbols union. Okay, union. So you have the symbols like a U. Okay, like a U. So this symbols is what we call the union. Okay, H union F. So it can be either human resource or female. Okay, it can be either human resource or female as long as the students or the graduates majors in human resource or is female, it will be included under here. Okay. So for this one, there are two ways to solve it. Okay, if we use we can use the addition rule formulas. Okay, we can use the addition rule formulas. So the addition rule formula says okay, A union B, the probability for A union B is A plus B minus the intersections. Okay, this is the addition rule formulas for this probability, for the union probability. Okay, so refer to this. Okay, you will take human resource plus the probability for female minus the intersections. So these three probabilities, you have found it in the previous questions, right? Okay, part 1, 2, and 3, yeah? So 0.5 plus 0.45 minus 0.2. Okay, you got 0.75. So the probability of you selecting majors, graduates majors in HR or female is 75%. Okay, the next question, the graduate is a female given that okay, he or she majors in human resource. So when you see given, that means this is a conditional probability questions. Okay, this is a conditional probability questions. So to calculate this, okay, you will look at, okay, how do you write the working first? Okay, so you have the probability, graduate is a female. Okay, so you write F in front. Okay, this is female. Okay, and then given that, okay, the symbols for given that is a stroke. Okay, So you can think of this stroke as given. Okay, female given what? Given major in human resource, which is the H. So F stroke H. Okay, which means what does it mean by this question is, okay, we know that the graduates majors in human resource. Okay, out of those who major in human resource, okay, what is the probability that the graduate is a female? Okay, so we will look at, the human resource column. Okay, the human resource column, how many of them do we have? We have 500. Okay, when you have conditional probability, meaning this HR, it happens already. Okay, we know that the graduate is a human resource majors. So if we know, then we will only focus on these 500 graduates. Okay, we only look at these 500. Okay, we don't look at the 1,000 anymore. Okay, because given this is the given event. Okay, this has already happened. Okay, we already know the graduate is human resource majors. So we only look at these 500s. Okay, out of these 500s, how many of them are female? Okay, so how many of them? 200s. Okay, out of 500s, 200s of them are female. Okay, so the probability will be 200s divided by 500s. So you get 0.44. Sorry, 0.4. Okay, or some students may want to use the conditional probability formulas. Okay, you can let it equals to, okay, the conditional probability formulas is this. Okay, A given B is equals to probability A intersect with B divided by PB. Okay, so if you apply to these questions, you have something like this. So you get, okay, F intersect with H is the same as part 3, H intersect with F, so 0.2. Then divide by H, answers in part 2, 0.2, sorry, 0.5. So 0.2 divided by 0.5, you got 0.4. Okay, so it depends on how you work on the answers. Okay, next questions. The graduate is major in HR. Okay, major in HR. Given that the graduate is a female. Okay, so what is the given event here? Okay, given that the graduate is a female, so we know that the graduate is a female already. So we will not look at, okay, we will not look at the 1,000. Okay, we will look at those who are female. So how many of them total female? 450. Okay, we only look at this 450 because we know the graduates, okay, is female. Okay, given already. Okay, given means it has already happened. Okay, so out of this 450, how many of them are majors in human resource? So we look at this row. Okay, we only look at this row. Just now we look at the HR columns. Now we look at this row, female row. Okay, out of this 450, 200 of them are from HR. Okay, 200 of them are from HR. So to write out the answers for this, okay, question 6. So how to write the symbols? The notations here should be H Okay, human resource given female. Okay, so to find the answers, you will take 200 divided by 450. So answers would be 0.44. Okay, or you can use the formulas. Okay, H-intercept with F divided by. So H-intercept with F, you got 0.2 and divided by PF. Okay, the probability for female, you refer back to the first question, 0.45. So you should get the same answer, 0.44. Okay, so if you compare question 5 and 6, okay, what can you tell? Okay, we can tell that, okay, the probability A given B is not equals to B given A, yeah? Okay, so F given H is not the same as H given F. Okay, because we are dividing by a different total. Okay, the given event is not the same. Okay, well, my handwriting is getting bigger. Okay. Okay, next questions. Question 7. Okay, the graduate is not a female. Okay, so we have only two genders here, male and female. If it's not female, that means it's a male already, right? Okay, so how do we write the probability notations? We have probability F complement. Okay, we have a bar on top, huh? Okay, which means this is complement, F complement, meaning not female. Okay, the bar on top, it means not. Okay, it is not female. So, okay, let's write down the formulas. Okay, if you want to find A complement, what you do is you take the total probability, okay, which is always equals to 1, minus the probability for A. So you take 1 minus, okay, in this case, you take 1 minus the probability for female. Okay, female is 0.45. So you get 0.55. Okay, so this is the probability for male. Okay, 55% of the graduates are male. Okay, next. Okay, next question. The graduates majors in accounting given that the students is male. So what is the given event here? Given event is the student is male. So if you look at the table, okay, let's clear this. Okay, so we will look at the male row this time. Okay, we will look at the male because this is the given event. So the total for male is 550. So out of this 550, how many of them majors in accounting? Hundreds. Okay, so the answers would be, okay, let's write down the notations here. Okay, accounting given male. So you will have, okay, the answers would be 100. Okay, divide by 550. So you get 0.18. Okay, or you could use the conditional probability formulas. Okay, A intercept with the male divided by the probability of mu. So this one you have to calculate it. Okay, since we don't have it in the previous questions. So what is the probability for accounting and meal? Okay, accounting and meal, we have hundreds. Okay, hundreds out of 1,000. Okay, how about the probability for meal? 550 divided by 1,000. Okay, how to get the probability is always the number divided by the grand total. Okay, so here is number of meal divided by the grand total 1,000. So whichever way you should get 0.18. Okay, next, next is, okay, the graduate is a male given that, okay, the graduate is a male given that he majors in accounting. Okay, majors in accounting. So given event here is majors in accounting. So what you do here is you look at the accounting column. Okay, where is the total for accounting? 220. Okay, and then out of these 220, how many of them are male? 100. Okay, so to calculate this, okay, male given accounting, okay, you will again have hundreds divided by 220. Okay, you get 0.45. Okay, so again here, the questions for these two probability, okay, they are different, right? Okay, A given M is not the same as M given A. Yeah? Please do not think that they are the same. Okay, next questions. Is the event graduate is female and majors in human resource independent? Okay, the last two questions is trying to prove whether the two events are independent or mutually exclusive. Okay, so let's look at independent first. Okay, how do we prove independence or not? Okay, to prove independence or not, okay, right, let's write here. So let's write some notes. Okay, so if the two events are independent, okay, if the two events are independent, then okay, the probability A intersect with B, it will be equals to A times B. Okay, there are actually two ways to prove. Okay, this is the first way, or the conditional probability A given B is equals to A. Okay, so so it depends on, I'm not sure which method you have learned, or maybe you have learned both. Okay, so you can use either one to prove. Okay, either the first one, A intersect with B, or you use the conditional probability to prove it. Okay, so I'm not sure which one you think is easier. So I'll leave it to you to decide. Okay, so for this one, maybe we can use what? the first way or the second way, doesn't matter. Okay, let me show both lah. Okay, so here we are looking at what event? Female and human resource. Okay, F and H. So first you find, okay, first you find F. What is the probability for F? Okay, we already found it just in the previous question, 0.45. H, how about human resource? 0.5, we found it already. Okay, how about the intersections? The F intersect with H. We also have it right in the previous questions, 0.2. Then you check, okay, using the first method, is F intersect with H equals to F times H or not? So is 0.2 okay equals to 0.45 times 0.5. Okay, they are not equals, right? If you press your calculator, they are not equals. So you will say, since the intersections is not equals to the multiplications of F times H. Okay, therefore, the event, the graduate is a female, and the human resource, they are not independent. Okay, this is the first way. Okay, the second way is you compare, okay. You compare what? Let's say F given H. Just now we have found this right in question 5. Okay, F given H is 0.4. F is 0.45. So you will say, since F given H is not equals to F, therefore, okay, they are not independent. Okay, with the same final answers. Okay, the two events are not independent. Okay, use either way to prove. Okay, any questions for this proving of the independence of two events? Okay, we have the last questions here. Okay, prove meal and accounting, whether they are mutually exclusive. Okay, so for these questions, question 12. Okay, let's try it here. Not much space here. Okay, sorry, question 11. This is question 11. Okay, so how do you prove? Okay, if the two events are mutually exclusive, okay, then, okay, first you need to understand, okay, what is mutually exclusive? Okay, mutually exclusive means the two events cannot happen at the same time. Okay, they cannot happen at the same time. So if they are mutually exclusive means their intersections. Okay, what is the chance for both of them to happen at the same time? Is equals to 0. Okay, as easy as that. So back to these questions, we are looking at meal and accounting. Okay, meal and accounting. What is the probability for meal and accounting? Okay, meal and accounting is hundreds divided by 1,000. Okay, we have 100 graduates who are majoring in accounting and MEO. Okay, so hundreds divided by 1,000. Okay, you get 0.1. So since the joint probability, the intersections is not equals to 0, therefore MEO and accounting are not mutually exclusive. Okay, because there is a chance for them to happen at the same time. Okay, therefore they are not mutually exclusive. Okay, is there anything you would like to ask? No?
No.
Okay, so we will take a break. Okay, we'll take a short break now. Okay, a 10 minutes break. Is that okay? So we will come back at 10:30, right? If we come back at 10:30 a.m. Vietnam time. So we'll take a 10 minutes break. Then we will continue with question 2. If you have any questions, then you can ask me after the break. Okay, so see you guys later. Okay, gonna take a rest. Come back after 10 minutes. Okay. All right. Is Aaron back? We will have to continue with the questions. Are you guys ready?
Yes, okay.
Hannah? Okay. So far, is there any questions you want to ask me? No? Okay. So let's continue with question 2. Okay, question 2 is you're given a discrete probability distributions table. Okay, you were asked, am I sharing my screen? Yeah, okay. So you were asked to find the mean and variance for the above probability distributions. Okay, so first understand this table. Okay, the first row x, okay, these are the possible values of for x. Okay, it could be -1, 0, 1, 2, and 3. Okay, and then the second row is the probability. So what is the chance of you getting -1? Okay, 0.25 or 25%. The chance of you getting 0 is 0.33. Chance getting 1 is 0.17. Okay, and so on. So you want to find the mean and variance for this probability distribution table. Okay, means on average. Okay, on average, what is the chance? What is the average lah? Okay, for the variable x. Okay, the mean for the x based on the probability. So the formulas to use here. Okay, let's move it a bit down here. Kind of, yeah, should be okay. So let's do it here. Question 2. So the formulas that we use, it will be, okay, you can refer to the last few pages, okay, to get the mean. A mean for the discrete probability, or we can write EX, okay, the expected values for X is equals to the total of X times with the probability. Okay, whereas the variance, okay, how do we get the variance? Is the total of x squared times the probability. Okay, minus the mean squared. Okay, mean is we will also use the symbol mu. Okay, something like a U. Okay, this is called mu. So this is the formulas to use here. So based on the table, okay, let's reconstruct the tables. Let's copy down the tables again. Okay, the tables given us is in row. Okay, we can convert to columns. It'll be easier for us to calculate. Okay, to do the calculations. Okay, px. Okay, px is the probability for each values of x. Okay, so first, what do we need? Okay, to calculate the mean, we need the x times the probability. We need this column. So how to get this? You take the x value times its probability. So you get negative 0.25. Okay, for the second value, we have x times 0.33. Okay, 0. Okay, so get 0. Okay, so do the same for the remaining x value. You got 0.17, 0.3, 0.3. Okay, so you add up the last column. Okay, you add up this column, you will get the mean already. Okay, so the mean will be equals to the sum of negative 0.25 plus 0 plus until the last value 0.3. Okay, so you get 0.52. Okay. Okay, oh yeah, not sorry. Let me rub off this part because I need some space for the next column. Okay, to find the x squared times px. I need space for this. Okay, move on to this. Okay, the mean mu is, yeah, you add up the 5 values. So you get 0.52. Okay, so mean is 0.52. How about variance? Okay, to calculate the variance, first you need to get the x squared times px. Okay, so x squared times px is you will square the x value first, then you multiply by its probability. So here you got 0.25. So do for every single values. Okay, so what is your total? Total x squared times px. So you add up the last column this time. Okay, 0.25 plus 0.25 plus 0 plus 0.17 plus 0.6 plus 0.9. So you get 1.92. Okay, then we can now calculate the variance. Okay, so this is the symbol for variance, called sigma squared. Okay, sigma squared. Okay, so you take 1.92 minus mean square. Mean is 0.52 minus 0.52 square. So you get 1.65. Okay, that's it. Okay, any questions?
Can you wait me a minute? I wrote it my note.
Okay. Give you a minute, right? You want to copy down the answers? Okay, let me know when you're ready to move on to the next questions.
Yes, thank you, teacher.
Yes. Okay.
Okay. Okay, for those who are ready, you read up the question 3. Okay, you're given another tables. Okay, a probability distributions tables. Okay, statisticians was employed to study the number of shops that a customer will actually enter. Okay, so for question 3, the table shows you the number of shops that the mall customer enter. Okay, you have 200 customers, right? You're ready. Okay, great. So let's look at question 3 now. Okay, this sample size. Okay, you have 200 customers now. Okay, and then what is the variables that we want to study? We want to study the number of shops that the customer will actually enter. So they will either enter 0, meaning they don't enter at all. What is the probability or the chance? 0.04, okay, 4%. Okay, the customer enter one shop, 19%. enter 2 shops, 3, 4, 5, maximum enter 6 shops. Okay, 6%. So, okay, based on this table, okay, find the probability. Okay, question 3. A1. Okay, find the probability that randomly selected customer enter 3 or more shops. Okay, so you want to find the probability X more than or equals to 3. So based on the table here, more than or equals to 3, you will have 3 plus 4 plus 5 plus 6, right? So we will add up the probability 0.28 plus 0.12 plus 0.09 plus 0.06. Okay, so the answer 0.55. So when you randomly select a customer, the probability that the customer enter 3 or more shops, okay, that means at least 3. Okay, at least 3, yeah? So it's 0.55. Okay, question 2. Randomly selected customers enter less than 5 shops. Okay, less than 5. How you write it? You will have probability X less than 5. So you need to know what symbols to use. Okay, less than, you use this. Okay, less than. So here, what are the values less than 5? You have 0, 1, 2, 3, and 4. Okay, so 0.04 plus 0.19 plus 0.22 plus 0.28 and 0.12. Okay, these are the probability for X less than 5. So add them up together, you get 0.85. Okay, question 3. Okay, the customers enter more than 1, but not more than 5 shops. Okay, so please careful with this word, not more than 5, meaning maximum is 5. Okay, can it be 5 shop? Yes. Okay, it can be 5, because not more than 5. Okay, it cannot be 6. Okay, 6 is more than 5, but 5 is not more than 5. Okay, so how do we write? How do you write the notations here? You have X more than 1. Okay, smaller values, we put it on the left. Okay, X more than 1. Okay, less than or equals to 5. So you will have the probability from where? Okay, more than 1, it can be 2, 3, 4, and 5. Right. These are the values more than 1, but not more than 5. So you add up these 4 probabilities. Okay, so the final answer 0.71. Okay, so question B is what you have done in question 2 just now. Okay, find the mean and standard deviations. So this time is looking for standard deviation. So you have to square root the variance. Okay, you have to square root the variance. Yeah. So to show the workings, I will suggest you to construct the table like what you have done in question 2. Okay, you have the X value. Okay, so list down the X value. Okay, and then the probability. Sorry, I think I 0.22, 0.28. Okay, oh, all right, too big already. Okay, 0.19, 0.2. Okay, 0.06. Okay, so we add a columns, calculate the x times the px. Okay, we add columns, calculate x times px. Okay, so use your calculator, calculate for every pairs. Okay, we also calculate x squared times px. Okay, x squared times px. So 0. Okay, 1 squared times 0.19, you got back 0.1. Okay, 0.88. This is 2.52. Okay, 3 squared times 0.28, you got 2.52. 2. Okay, I'm not showing the workings here. You can sure press it in your calculator. Okay, so what is the mean? The mean would be the total of the x times px. Okay, you add up this x times px, you will get a total already. Okay, so total is 2.76. This is 9.92. So the mean is equals to 2.76. How about the standard deviations? So standard deviations, the symbols we use is sigma, okay, without the square. So square root of total x squared times px, 9.92, minus the mean square, 2.76 square. Oops. Yeah, we erase the whole thing. Okay, so press your calculator to calculate this, you would get 1.52. Okay, any questions? Okay, I will highly recommend you to try out the questions first. Okay, before you attend this revision class, because I'll be discussing the answers. Okay, mainly on the answers, and then if you don't understand any concept or theories behind, then I will explain it to you. Okay. So if you have never read the questions, if you have never tried it, right, you may not understand what I'm doing. Okay, you're just copying my answers. Okay, so you don't know what has happened. Okay, you just copy and then you study later. Okay, hopefully you understand. Okay, but how if you don't understand after these 4 days? Okay, you go and study yourself. Okay, and then you don't know what you're copying or what I'm writing. So if you have tried before you attend, then when I discuss, if there is some parts you don't know how to do, at least you can ask me. Okay, like right now on the spot. Okay, can I proceed to question 4? Move on to question 4.
Yes. Okay.
All right, question 4 is chapter 5 questions ready. Okay, just now question 1, 2, 3. Okay, these are the chapter 4 questions. Now we move on to chapter 5, okay, which has the binomial and the Poisson distributions. Okay, these two are the discrete probability distributions. Okay, so question 4. Okay, the probability that the housing loan applications will be approved is 0.4. Okay, find the probability in the random sample of 15 housing loan applications. Okay, these numbers of applications will be approved, okay, or will not be approved. Okay, question 4A, part 1. Okay, so before that, okay, let's write down what are the informations we have. Okay, we know that the sample size, okay, so we know that X is what? Okay, let X to be the applications will be approved. Applications will be approved. So X, it follows a binomial distributions. Okay, why is it follow binomial distributions? Because for every applications, it has only two outcomes, either approved or not approved. Okay, so binomial distributions has only two outcomes. And then where's the sample size? 15. Okay, what is the probability of success? Okay, every time when you randomly select an applications, the chance for it to be approved or for it to be success is 0.4. Okay, so find, okay, exactly 3 will be approved. So you need to know the formulas first, okay, for binomial. Okay, the formulas is NCX, PX, Q power N minus X. Okay, I think you can see it in the last few pages. Yeah, yep, this one. Okay, Poisson later on, okay, you refer to this one. Okay, so most of the formulas you can find it in these formula sheets already. Yeah, so whenever I write the formulas, please refer to these last few pages. Okay. So here, you want to find the probability. Exactly 3 applications will be approved. So X, okay, X is the number of applications to be approved, right? Is equals to 3. So you will use the formulas, okay, to calculate the probability. N is 50. So basically, all the values are given already, right? Okay, all the values are given. It's just that you need to know how to substitute into the formulas and then press in your calculator. Okay, P is 0.4. Power 3. Okay, how to calculate Q? Q is equals to 1 minus P. Okay, Q is the probability of failures. Okay, P is for success. So failure here is 0.6. Power what? N minus X. So 15 minus 3. Okay, you got 12. So press in your calculator. Okay, you should have 0.0634. Okay, by using the calculator. Okay, you guys also have the statistical tables with you, right? Okay, I've shared the statistical table. Let's see. Where is my statistical table? This one? Statistical formula. This is formula. Statistical table, this one. Okay, I believe you have the statistical table with you, right? Okay, let me import it to OneNote. Okay, this is the statistical table. Okay, so in this statistical table, you will see the table for binomial distributions, table for Poisson distributions, and then a table for normal distributions. Okay, first we look at the binomial. Okay, so sometimes when you want to find the probability, you can actually find it from this binomial table. Okay, but there are some limitations here. There are some limitations. Okay, only if your n, okay, it's the same as the tables. So you have 1, 2, 3, 4, 5. Okay, and then it jumps to 10 already. So if your n is equals to 6, 7, 8, or 9, then you cannot refer to this table. Okay, or if your n is 11, 12, 13, 14, you also cannot refer. Okay, so only a specific sample size you can refer to here. Okay, up to 25. Okay, and also you have to look at the p. Okay, the probability of success. If your probability of p is 0.05, 0.1, 0.2, then you can refer to this table. If let's say if your probability of success is 0.15, then you cannot refer to this. Okay, you have to use the formulas to calculate. Okay, so let's say for these questions, your n is 15, p is 0.4. So can you refer to these tables or not? Okay, you can, right? Okay, you can. So you look at n equals to 15, and you look at the columns 0.4. Okay, so you go all the way down. So these are the probability that you look at. Okay, these whole columns. So you see there is x value here. Okay, this x value. So the first value tells you the probability x equals to 0. Okay, x equals to 1, x equals to 2. So right now you want to find x equals to 3. So the probability is 0.0634. Okay, so if you can find the probability from the statistical table, okay, then you can straight away write down the final answer. Okay, without using the formulas. Okay, this is fine. Yeah? Okay, if you can straight away find it from the table. Okay, do you understand what I'm saying? So that means you don't have to write these steps. Okay, you can straight away write 0.0634. Okay, move on to the next questions. 3 or less will be approved. So x less than 3. Okay, so x less than 3, you could have the probability x equals to 0, x equals to 1, x equals to 2. Okay, that's it. Okay, you cannot have x equals to 3. Okay, sorry, 3 or less. Oh, 3 or less means less than or equals to 3. You could have 3, yeah? So x equals to 3. Okay, so either you use the formulas or you refer to the table. Okay, for these questions, you can refer to table, then we refer to it. Okay, if you can't refer to the table, then you have to substitute into the formulas. Okay, so for example, x equals to 0, you have 15c0, 0.4 power 0, 0.6 power 15. So this is the probability for x equals to 0. Then you plus x equals to 1. So you have to write out, okay, for all the probabilities. Okay, so if you guys fill in yourself. Okay, so if you can refer to the table, then let's look at the table here. So this time we will look at what? X equals to 0, X equals to 1, 2, and 3. Okay, these four probabilities. Okay, so just straight away write down the probability. 0.0005. So when we are solving probability questions, please leave your answer in 4 decimal places. Okay, please use 4 decimals for probability questions. Okay, so here x equals to 1, x equals to 2. Okay, so x equals to 1, x equals to 2, and then x equals to 3. Okay, let me know if my workings are wrong. Huh? Okay, sometimes my answers could be wrong. Huh? If I add up wrongly or the probabilities that I write is wrong. Okay, so far, can you guys follow? So
Yes, okay.
can, huh? So for these questions 4, basically you just read the questions and then you sum up the required probabilities. So for question 3, less than 3 will be approved. Okay, so this is similar to question 2. Okay, but this time you don't include 3. Okay, so you have x equals to 0, 1 and 2 only. So I'll just copy the probability from question 2. Okay, since you have calculated manually or you refer to the tables already. Okay. So this is the answer. So this is just to test you, okay, when you see different kind of words, okay, what are the inequality sign that you use only, yeah? So you need to know, okay. So less than 3 you use less than, okay, the arrow to the left, okay, at least. Okay, question 4 is at least 3. So the symbols we use will be more than equal. Okay, more than or equal to 3. Okay, so here more than or equals to 3, the x value could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, up to 15 because your sample size is 15. So because there are too many probabilities that we have to add up. Okay, we have to sum up. So we don't add up from 3 to 15. Okay, we take the total probability, we minus off the probability less than 3. Okay, because the possible values for x are okay, the possible values for x, it could be any values from 0, 1, 2, 3, 4, 5 until 15. So right now we want to have more than or equals to 3. Okay, so we want to have this part. So we take 1 minus the probability less than 3, which is 0, 1, and 2. Okay, 0, 1, and 2. So this one is actually, we found it in part 3 already, right? So 1 minus 0.0271. Okay. Okay, question 5. between 4 and 7 inclusive. So the word inclusive here means it includes 4 and 7 as well. Okay, includes 4 and 7 as well. Okay, so for these questions, let me write this side here. Okay, so how do we write the notations? 4 and 7. So x is between 4 and 7. So you need to have the equal sign, yeah? The equal sign below, inclusive. So you will add up probability 4, 5, 6 until 7. Okay, so you refer to the statistical table. Okay, since we can refer to it. This time you look at 4, 5, 6, and 7. Okay, you should get the same probability if you are calculating it using formulas. Okay, so let's write down the probability. 4, 5, 6, 7. Okay, let me know if you don't understand any parts here. Okay. Okay, answer 6964. Okay, next questions. More than 3 but not more than 8. So just now we have seen these words, right? Not more than means maximum. Okay, maximum is 8. Can it be 8 applications? Yes, can. It can be 8 applications. So more than 3, not more than 8. So less than or equals to 8. Here's some sound. Do you have questions? Someone has questions for me? If you accidentally unmute your mic, please mute it back. Okay, add up until 8. Okay, 4, 5, 6, 7, and 8. So you have to add up, yeah, these 5 probabilities. So again, refer to the statistical table. Okay, I'll just copy down the probabilities. Okay. Right. Next questions. Question 7. Okay, question 7 a bit special here. Okay, the question say will not be approved. Okay, so far all the questions is asking will be approved. So 7 and 8 is asking this number of applications will not be approved. So we need to do some adjustment on the probability of success. Okay, the P. So just now our X, okay, our X here is the applications will be approved, right? Now we have to change it to a different one. Okay, our X here now is equals to the number of applications will not be approved. Okay, so what is the probability of success? Okay, what is the chance for the probability not be approved? Okay, sample size is still 15, but the probability of not approved. Success means not approved here is 0.6. So for questions 7 and 8, you need to use P equals to 0.6. Okay, don't use 0.4. So please read the questions in the exam carefully, whether let's say for these questions, approve or will not be approved. So make sure you use the correct P value. Okay. So meaning for these questions, instead of looking at the P 0.4, you will look at the P equals to 0.6. Okay, you look at this column, this column. Okay, for 0.6. Okay, so here you want to find between 3 and 7 applications will not be approved. So you don't see the word inclusive here. That means you don't include 3 and 7. Okay, you do not include 3 and 7. Huh? So what is the possible X value? 4, 5, and 6. Okay, between 3 and 7, but you don't include 3 and 7. Okay, so use either the formulas or the statistical table. Okay, you refer to what? 4, 5, 6. Correct, right? Okay, 0.245, sorry, 0.0245. 0.0245. And then x equals to 6 is 0.0612. Okay, you add up yourself. Okay, see where is the answer. Okay, question 8. Question 8, at most 2 applications will not be approved. Okay, at most, okay, that means maximum is 2. Okay, it means maximum is 2. So the inequality sign that you should write is less than or equals to 2. So here you add up 0, 1, and 2. Okay, so if you look at the statistical table, now you add up 0, 0, and 0.0003. Yeah, 0, 1, 2. Okay, oops. 0, 0, 0.0003. Okay, so what is the probability at most 2 applications will not be approved? 0.0003. Confirm? Yeah, correct. Okay. Any other questions? No. Oh, find the mean and variance for the above binomial distributions. Ah, okay, mean and variance. Okay, so for part B, to find the mean, okay, these are all formulas. Okay, mean for binomial is n times p. So n is 15. Oh, okay, the questions for the above binomial. Okay, we will use back the original p given. Okay, let's say it's for approval. So mean for approve, okay, use for this 0.4. Okay, 6. Variance. variance, okay, the symbol is sigma square. Okay, formula is NPQ. Okay, answer 3.6. Okay. Okay, any questions for these binomial questions? Is there anything you want to ask? Let's see the chat. Okay, nobody's joining the chat to ask me questions. Okay, it's fine. Okay, can I move on to question 5?
Okay.
Can I? Okay, let's move this. Okay, question number 5. Okay, this is also a binomial question. So a used car determined that 30% of the customers made a complaint about the car within 1 month of purchase. Okay, so this is the chance or the percentage of customers made complaint. Okay, what is the sample size? Okay, sample size is 8. Okay, so what is the probability that out of 8, okay, only one made a complaint? Okay, so let's write down the information here. Okay, X is equals to number of complaints. Okay, so X follow a binomial distributions. Okay, sample size is 8. What is the probability? 0.3. Okay, so for question 5A, part 1. Okay, you want to find probability X equals to 1. Okay, so if you look at the statistical table, do you have n equals to 8? Don't have. Okay, 5 jumps to 10 already. Okay, unless you have the statistical table for n equals to 8. Okay, if you have n equals to 8, then you can use the statistical table. Okay, if not, then you have to use the formulas already. Okay, so you have to write down the formulas, substitute the values in the formulas first. 8C1, 0.3 power 1, Q is 0.7 power 7. So by calculations, you get 0.1977. Okay, part 2, less than 2. Okay, so make sure you read the keywords are more than 2 but not more than 6. At least 2 but not more than 6. Okay, so here less than 2x, less than 2. So it means 0 and 1. Okay, so I'll show you one more time. Okay, how to write the proper workings. So for the subsequent questions, I don't write down the formulas anymore. The substitutions into the formulas. So here, 8C1, sorry, 8C0. Okay, x equals to 0. P power 0. Q power 8. Okay, this is for x equals to 0. Then this is for x equals to 1. So later I will skip these steps. Okay, you look at the formulas and you substitute it inside. Okay, according to the x value. So here, press your calculator. You should have the 0. Okay, the probability less than 2 make complaint. Okay, the probability is 0.2553. Okay, question 3, at least 3. Okay, at least 3 means more than or equals to 3. So right now you have 8 customers. More than or equals to 3 means you could have 3, 4, 5, 6, 7, and 8. Again, I think there is too many to calculate. So what I'll do is I take 1 minus less than 3. So means I'll take 1 minus 0, 1, and 2. Okay, so you guys write down the substitutions into the formulas. Then I'll straight away give you the final answer for the probability. Yeah. Okay. 1977. Okay, this is the answer for question 3. Okay, question 4. More than 2, but less than 6. So how many complaints are there? Okay, more than 2 means you could have 3, 4, and 5. Okay, because it has to be less than 6. So 3, 4, 5. Okay, 3, 4, and 5. So how to write the notations here? Smaller values is always on the left, largest values is on the right. So more than 2, less than 6. Yeah. So you have 3, 4, and 5. Okay, I'll straight away give you the probability. You guys calculate using the formulas. And you check whether is it same as mine. Okay, let me know if my answer is wrong. Okay, next questions, more than 2. Okay, same as the previous questions, more than 2, but here is not more than 6. Okay, means maximum is 6. We have seen these words quite a number of times. Maximum is 6 means you could have x equals to 6, right? So see the difference between question 4 and question 5. Okay, the difference is this. This is less than, this is not more than, maximum is 6. So it will be same like the previous questions, but you could add up until 6. Okay, so 4 plus 5 plus 6. 3, 4, 5, and 6. Yeah, 6. Okay, 0.74. Okay, wait. I copied the wrong answers. Yeah. sorry, I copied wrong. This should be the next questions. So here, probably x equals to 6 should be 0.01. Okay, 0.4469. Okay, and then question 6, at least 2, but not more than 6. Okay, at least 2 means now you will include 2. Okay. So you have equal sign on both. Okay, you have equal sign here. Right? So you add up 2, 3, 4, 5 until 6. Okay. So probably x equals to 2 is 2, 9, 6, 5. Okay, I will add up the answer from question 5. Okay. Because this probability is 3, 4, 5, and 6. So you don't have to, okay, if you can make use of the answers from the previous questions, okay, then you just copy down. Okay, like what I did here. Instead of writing the same values again. Okay. Okay, this is the answers. And then find the mean and standard deviations. Okay, so mean and standard deviations here. Mean is the mu n times p. Okay, standard deviations, the symbol is sigma. Okay, so just now we found variance, right? Now we find standard deviation. So you have to add the square roots. Okay, any questions?
No.
No? Okay. Okay, how many questions are there in module 2? Wow, we have 12 questions. Hopefully we can finish by today, module 2. Okay, if there's no questions, I'll move on to question 6. Okay, you guys read the question 6. Okay, car arriving at the petrol stations with a mean of 36 cars per hour. So this is a Poisson questions. Okay, so in Poisson distributions, we don't look at the probability. Okay, and then we don't look at the sample size. Okay, we just look at on average. Okay, on average, how many occurrences are there? Okay, meaning in this case, how many cars are there within a time period? So the time period here is in 1 hour. Okay, in 1 hour, how many cars do we have? 36. Okay, 36 cars. So this is a Poisson questions. Okay, so let's write down the information here. Okay, you have, maybe let's use a different color, okay, to differentiate question from question 5. So X is what? X is the number of cars arrival, the number of cars arrive. Okay, so X follow Poisson distributions. Okay, so this is a symbol, or you write P. Okay, it follows. So questions will always tells you the mean. Mean is the average, which is also the lambda. Okay, the symbols for lambda. Lambda equals to 36 per hour. Okay, so this is the mean. Mean is the lambda. Okay, what is the mean number of cars arriving at the petrol stations per 5 minutes and per 10 minutes? So we know that average 36 is for 1 hour. So how about for 5 minutes? How many cars are there? So we have to do divisions. Okay, we have to divide. Yeah? So where is the mean per 5 minutes? Okay, 1 hour 36 cars, 5 minutes, how many cars? Okay, you have to do some simple calculations lah. Okay, so you take 36 times 5 divided by 60. Okay, 5 over 60. So in minutes, you divide by 60, then you have times 5. So that means on average, you have 3 cars. Okay, per 5 minutes. So okay, so how about 10 minutes? How many car on average? So take 36 times 10 divided by 60. So you got 6 cars. So on average, every 10 minutes, 6 cars will arrive. Okay, every 10 minutes, 6 cars will arrive. 60 minutes, which is 1 hour, 60 minutes, you have 36 cars. Okay, makes sense, huh? Makes sense, huh? So you have to do some adjustment here, okay, when the time period is different. Okay, question 2. Find the probability in the next 5 minutes. 2 or less cars will arrive at the petrol stations. So one special thing about the Poisson question is, okay, the time periods may be different, okay, for each questions. So even though question tells you per hour, okay, but the questions when they ask you to calculate the probability, it asks for 5 minutes or it asks for 10 minutes, okay, or even 45 minutes. So when the time period is different, you have to adjust the mean, which is the lambda. Okay, this is actually the lambda that you are going to use later when you find the probability. So don't straight away use 36. 36 is for 1 hour. Okay. So for question 2, for 5 minutes, okay, you will use lambda equals to 3, okay, per 5 minutes. Okay, so the formulas for the Poisson distributions, if you look at the formula sheets, is E negative lambda times lambda power x over x factorial. Okay, so this is the formulas to calculate the probability, okay, for Poisson distributions. Okay, so you want to find 2 or less. Okay, probably 2 or less means less than or equals to 2. So you add up 0, 1, and 2. Okay, so you can either use formulas. So if you are using formulas, then you substitute lambda equals to 3. 3 power x over x factorial. Right, 3 power 2 over Okay, so press this in your calculator one by one. Okay, let's see whether we can find it from the statistical table. Okay, so we're going to look for Poisson table. Okay, so Poisson table, you can refer this if your lambda is the same as the table. Okay, there are 2 pages here. So right now we have our lambda equals to 3, right? So we can actually refer to the table. So let's say if your lambda is 3.2, then you cannot refer to the table anymore. Okay, so here x equals to what? Okay, you want to add up 0, 1, and 2. Okay, so you look at this 3x value. Okay, so back to, okay, so same like the binomial distributions. If you can straight away find the probabilities from the table, then you don't have to write down these steps. Okay, you can straight away write down the probability. Okay. But if you can't find it from the table, then please use the formulas. Okay, so this is the answer. Okay, question 3. Find the probability in the next 5 minutes. Okay, so this question is also using 5 minutes. Exactly 2 will arrive. Okay, so this is simple. Just find x equals to 2. So previous questions, you can just copy it from the previous questions. 2, 2, 4, 0. Okay, question 4. In the next 5 minutes, 4 or more cars will arrive at the petrol stations. So 4 or more. Okay, 4 or more means more than or equals to 4. Okay, so please take note that in Poisson distributions, there is no limit for the x value. That means, okay, your x value, okay, the x value, right? It could be from 0, 1, 2, 3 until infinity. Okay, because we don't know how many cars will arrive. Okay, it could be 100 cars. Okay, who knows, right? Okay, maybe the chance is very low, but there is still a probability. Okay, there's still a chance for it to happen. So what we do here is instead of calculating, you sum up 4, 5, 6, 7, 8, 9, 10. Okay, you add up all the values going up. So what we do is we take 1 minus the probability less than 4. It'll be easier. Okay, you have lesser calculations. 1, 2, and 3. Okay, so 1 minus these 4 probabilities will get you the answers ready. Okay, so again, you can refer to the statistical table. More than or equals to 4. So 1 minus. So we actually found 0 in the second questions, right? Yeah, it's okay. Just copy back. 0, 1, 2. Okay, if you want to straight away minus the answer in part 2 also can. Okay, but you have to add another one, minus 0.2240. Okay, so the answers would be 0.3528. Okay, make sure you guys know both methods. Don't depend too much on the statistical table. Okay, how if your lambda is 3.3? If you cannot refer to the table, then you have to use the formulas really.
I can ask you about the table you will use.
Yes, I'm referring to this Poisson table. Why?
I just want to know the table.
Yeah, this is the statistical table that I refer to. Okay, you can straight away extract, copy out the probability. Okay, so right now, just now we use until x equal to 3, right? So until here. Okay, next questions. Find the probability in the next 10 minutes. So the time period now is changed to 10 minutes. More than 1, but less than 6 cars will arrive. Yeah. Okay, so for these questions, okay, you will use lambda equals to 6. Okay, we have found in part 1, 6 for a time periods of 10 minutes. Okay, lambda, you use 6 here. So this time what we want to find, x is more than 1. Okay, more than 1, less than 6. So the probability could be x equals to 2, 3, 4, 5. 3, 4, and 5. Okay, so this time if you're referring to the statistical table, make sure you look at lambda equals to 6. Okay, and then what are the x value you refer to? More than 1 means look at 2, 3, 4, and 5. Okay, this 4 columns, sorry, these 4 rows, these 4 rows, 2, 3, 4, and 5. Okay, you add up these 4 probabilities, then you get the answers really. Okay. Nine. Okay, the last question, 6. Okay, find the mean and standard deviations of car arriving at the petrol stations in the next 45 minutes. So time periods now is 45 minutes. It will be same like the first questions. We have to adjust the mean, right? Okay, which is the lambda. So mean per 45 minutes. Okay, so this is actually the lambda, yeah, is equals to, you take 36 times 45 divided by 60. So you get 27. Okay, so there will be 27 cars, okay, on average to arrive in 45 minutes. Okay, so your mean is equal to 27. How about standard deviations? Okay. Your standard deviations, if you look at the formulas for Poisson distributions, is square root of lambda or square root of mean. Okay, because in Poisson distributions, mean is equals to lambda. So what you do is just square root 27. Okay, 5.196, so 5.2. Okay, any questions? Okay, so copy down the answers or
No.
no? Okay, great. We'll discuss one more questions. Okay, we discuss one more questions, then we'll go for a break already. Okay, because later I'm afraid later we can't finish all the questions here. So let's go a bit faster this time. Okay, question 7 is also a Poisson questions. Okay, so the average number of patients visiting a clinic between 3 p.m. and 7 p.m. is 20 patients. So you're given where is the lambda? Okay, lambda is equals to 20. Okay, on average, you got 20 patients. For how long? Okay, 3 to 7 p.m. Okay, for 4 hours. Right. Okay, the time period is 4 hours. So lambda equals to 20 for 4 hours periods. Okay, so okay, question 1. Okay, find the probability exactly 10 patients visit okay on a particular days between 3 and 5 p.m. Okay, so what is the time periods given here? This is 2 hours. Okay, so you need to adjust accordingly. Yeah? Okay, 4 hours you got 20. Okay, 2 hours, how many do you expect on average? Okay, so you have to find the mean per 2 hours. So which is the lambda. Okay, find the new lambda, yeah? Okay, so you take 20 times 2 divided by 4. Okay, so means you divide by half lah. Okay, you divide by half, that means you got 10. Okay, so you expect 10 patients per 2 hours. Okay, so here you want to find x equals to 10. Okay, so can you refer to the statistical table? Okay, you look at, do you have 10? Yes, you actually have 10. Lambda equals to 10. X equals to 10. So the probability is 0.1251. Okay, or you could use formulas. Okay, if you can't find it in the statistical table, then what to do is you use the formulas E negative lambda times lambda power x divided by x factorial. So whichever methods, you should get the same answer, 0.1251. Okay, question 2. Between 3 and 5 p.m. again. So don't have to, you can use the same lambda. Okay, 10 for 2 hours. Okay, so for these questions less than 4, you want to find x less than 4. So add up from 0, 1, 2, and 3. Add up these 4 probabilities. Okay, so I will just refer to the statistical table and then copy out the answers. Okay, so you refer to 0, 1, 2, and 3. These 4 values. Okay, so add up these 4 values, you should get the answers. Wait. Less than 4. Yeah. Okay, so all right. Okay, next questions. At least 4 patients, but what is the time periods here? 3 and 4 p.m. So now you have only 1 hour. Okay, then you need to adjust the lambda again, right? Okay, so for question 3, okay, the mean per hour or per 1 hour, the new lambda would be what? Okay, 4 hours, on average, you expect 20. 1 hour, how many? You don't expect 20 in 1 hour also. Okay, so your times 1 divided by 4. So you expect only 5. Okay, on average, 1 hour, 5. So 2 hours, 10. Okay. So question 3, you use lambda equals to 5 here. Okay, so you know 5 at least. Okay. So just now was less than, now is at least. So here the symbols, the inequality sign, the inequality sign you use should be more than or equals to 4. So again, just now I've mentioned that x can be any values up to infinity. So what you do is take 1 minus the probability less than 4. So do not straight away minus the answer in part 2. Part 2 lambda is using 10, but this question is using 5. Okay, do not minus straight away minus 0.0104. So you minus 0, minus 1, minus 2, minus 3. Okay. So I will skip some steps here. So write down the probability. This one also I can refer from the statistical table. Okay, make sure you look at lambda equals to 5, not equals to 10. Okay, the columns lambda equals to 5. Okay, let me double check. Okay, so don't look at this page. Look at this one, lambda equals to 5. Okay, 0. Take 1 minus these 4 probabilities. All right. Okay, where is the answers? Final answer should get you 0.735. Okay. Okay, the last questions. Okay, find the mean and variance number of patients visiting between, okay, the time periods here, 3 and 4:45 p.m. Okay, so this one is not just in hours, okay, but we have minutes as well. Okay, 4:45. So the durations here is what? 1 hours and 45 minutes. Okay, so what do we do? Okay, we convert 1 hours and 45 minutes. We convert all to hours. 1 hours to 45 and 45 minutes, right? Is equals to 1 point what hours? Okay, so we need to convert 45, okay, to hours. So we divide by 60. Okay, 45 divided by 60 is equals to 0.75 hours. So 1 hour 45 minutes is 1.75 hours. Okay, so why do I change all to hours? Because later we're going to change our mean again. So the mean, here, let me change the color. Okay, so the mean for 1 hour or 1.75 hour is equals to, you take the 20 times 1.75 divided by 4. Okay, so you got 8.75. Okay, so this is the average. Okay, 8.75. Okay, so this is the mean or the lambda. Okay, 8.75. How about variance? Okay, for Poisson distributions, variance is the same as the mean. So here you get 8.75 as well. Okay. So for any questions you want to ask?
Why question 3 add 2 down calculated mean?
Oh, I did calculate for question 2. Question 2, I'm using 10, right? How do you get this 10? You refer to question 1. Because the time period is the same. For question 1 and question 2 is the same. So we don't have to calculate it again. We can use 3, we use 10. For question 3, I did calculate. Okay, this is the calculations. Lambda is equals to 5.
Yes.
Did it? So whenever you have a new time periods, then you need to calculate the new lambda. If the time periods are all the same for all the questions, then you just have to calculate once. Okay, just calculate one time if the time periods are all the same.
I can see again the question 4.
4, okay. Any other questions? So we will take a break now. Okay. We'll come back after 1 hour. Okay, so we'll come back at 1 p.m. Okay, Vietnam time. If you have no questions for me.
Yes. No, I have a question.
Okay, so do you need me to show this page for you to write down the answers, or I can just unshare my screen? Anyone still copying the answers? No?
I write in my notebook.
Okay, so or you can screenshot this page. Okay, you screenshot and then I will stop sharing my screen already. Okay, I have to stop.